Welcome to an extraordinary episode. This week's Starship Flight Test 4 needs no introduction. I witnessed one of the most breathtaking events ever, and I can't wait to share every thrilling detail with you. But before we dive into the main event, let's not forget the other significant happenings from this week. Now, without further ado, let's get into the heart of it. We'll take a closer look at SpaceX's preparations for this monumental test. Remember last week's update where we saw the flight termination system being installed on both Booster 11 and Ship 29? Well, this past week was all about getting these giants ready for action. Ship 29 was meticulously moved away from the launch pad, signaling it was nearly showtime. With all systems checked and the final green light given, it was time to see Ship 29 and Booster 11 come together. A sight to behold. The precision with which Ship 29 was hoisted by the arms, pivoted over the booster, and then smoothly lowered into place was nothing short of engineering ballet. As the sun dipped low in the sky, SpaceX captured some stunning images of the integrated vehicle, poised for what promises to be a flight test to remember. Join me, Marcus House, as we launch into the details of this epic week for SpaceX's Starship program. Let's go! Once again, we witnessed the dynamic movements of Ship 29 as its transport stand was wheeled away from the towering arms and positioned near what was once the bustling suborbital section of the launch pad. In a remarkable moment captured by the Starship Gazer, we got a clear view of the heat shield on the ship. SpaceX has shed some light on this. The missing tiles are not a cause for alarm, but deliberate test points. These are designed to measure temperature extremes at those specific spots, offering crucial data. It's essential to remember that SpaceX is keen on understanding the possible scenarios if a tile were to detach during flight. Just over a week ago, Elon Musk noted that, currently, Starship might not withstand the loss of even a single tile in most areas, as the underlying material probably wouldn't hold up against the intense heat of re-entry. This makes every test even more vital. This particular area of the ship, below the skirt, is chosen for testing because it lacks critical structures like propellant tanks or the payload bay, making it ideal for such high-stakes experimentation. Interestingly, despite the Raptor vacuum engine sitting just behind these patches, the potential re-entry damage is less concerning. The critical maneuvers, the landing flip and the subsequent soft splashdown, are handled by the sea-level engines, not the vacuum ones. So, as we dive deeper into the mechanics and strategies of SpaceX, it becomes clear. Every piece of data, every test, brings us closer to the stars. Stay tuned as we continue to explore the fascinating intricacies of these groundbreaking space missions. In an unexpected turn of events, SpaceX decided to lower Ship 29 back to the ground just one last time. After detaching the ship's quick disconnect, they carefully sealed the ports with tape, ensuring no debris would compromise the spacecraft. With less than 48 hours to go before its first launch attempt, Ship 29 touched down once again. Initially, I thought perhaps they were adding the familiar branding and S-29 decals we've seen in previous missions. But, it turns out, this was more than just cosmetic. It was a swift tweak or test, because in no time, Ship 29 was hoisted back onto Booster 11, ready for action. Now, let's talk about Flight 4 itself. Just last week, we were eyeing a launch on June 5th. However, shortly after our last update, SpaceX announced a slight delay, pushing the date to June 6th. This gave the team a bit more time for those final preparations and regulatory approvals, a 24-hour shift that could make all the difference. For Flight 3, the FAA's launch license came through just 15 hours before liftoff, keeping us all on the edge of our seats. This time, however, things moved much quicker. The license was issued on Tuesday, a full 40 hours before the scheduled flight. Alongside the license, the FAA made a statement that I believe is crucial for understanding the broader implications of these tests. Certainly. Here's a more captivating and streamlined rewrite of your script. In this latest launch, SpaceX put forth a proposal outlining 3 scenarios where a mishap investigation wouldn't be necessary. The first scenario involves the failure of the thermal shield under extreme heat. The second, a situation where the flap system might not provide adequate control due to high dynamic pressure. And the third, a potential failure in the Raptor engine system during the landing burn. Impressively, the FAA agreed with SpaceX's assessment, indicating that no investigation would be needed for these scenarios as long as there was no injury or unrelated property damage. This is a significant win for SpaceX, as bypassing these investigations can save an immense amount of time and resources. It's a clear sign of regulatory confidence in SpaceX's risk management and mission planning capabilities. Moreover, the FAA's approval extends to enhanced mission profiles for both controlled and uncontrolled re-entries of the Starship in the future. This gives SpaceX the flexibility to choose the most appropriate re-entry strategy, an advantage that could be crucial for future missions, including those involving Ship 26. With every detail meticulously in place, the anticipation was palpable. The road closure happened right on schedule at midnight, extending even beyond the usual boundaries. Everything was set, and as the launch approached, I joined the live stream from NASA spaceflight, eagerly participating in the vibrant chat. The stage was set for a groundbreaking event. As the tank farm began its slow, steady preparation, I'd like to extend a warm thanks for the hospitality to everyone involved. The tower arms gracefully positioned themselves for launch, but a snag appeared. Cars unexpectedly returned to the pad. However, it was a minor hiccup, nothing to dampen our spirits, as the countdown continued without pause. Suddenly, the chimes of the booster echoed through the air, signaling the start of CO2 loading, a sure sign that launch was imminent. By T-2 hours, all vehicles had cleared the area, and SpaceX confirmed a new launch time, 7:50 a.m. local time. A slight delay, just a small issue with ground service equipment, was quickly handled. I was deep in conversation with the Lab Padre and Spaceflight Now teams as the event unfolded, and the excitement was palpable. When SpaceX kicked off their live stream, the anticipation reached new heights. The visuals were absolutely staggering, like the stunning view of the booster's forward section as the ship engine chill began. With 0 holds and no further complications, the countdown raced toward liftoff. And what a liftoff it was! Despite one of the outer Raptor boost engines flaming out just after takeoff, the mission pressed on without missing a beat. The ascent was nothing short of spectacular, a testament to the engineering marvel that is SpaceX's rocket. Despite the capability to endure the loss of a few engines if necessary, the booster performed flawlessly as it sliced through the cloud layer. Just above the clouds, shock waves danced around the vehicle, a breathtaking sight captured in 3 different camera angles at precisely 2 minutes and 52 seconds into the flight. This moment, reminiscent of Flight 3, marked the seamless hot staging choreography, an intricate dance of engineering precision. As the ship continued its celestial journey, the big question lingered. Would we witness significant improvements in the booster's return this time around? The answer came quickly and decisively. The boost backburn of the 13 Raptor engines was a sight to behold, cutting off simultaneously without a hitch, unlike the issues encountered during Flight 3. And then, in a moment of awe, the hot staging ring was jettisoned, a spectacular view never seen before. SpaceX confirmed live on stream that this maneuver was designed to reduce the mass of the booster, a temporary yet ingenious solution. With the mission progressing smoothly, it was now time for the booster to make its way back to Earth for a pinpoint landing and a gentle splashdown. The camera views were stunning, especially those showing the forward dome of the booster. Pay close attention, and you might even spot the grid fin actuator in motion, a subtle yet fascinating detail against the backdrop of space. As the booster screamed into the upper atmosphere, an exhilarating view from below captured the hot staging ring zooming past. Looking straight up, the camera offered a spectacular perspective as we ascended through layers of atmosphere. You could see the grid fins delicately making small corrections, guiding us as we soared past the 10-kilometer mark. As Booster 11 began its descent through the thicker layers of the atmosphere, a brief flurry of debris flew off. For a moment, it seemed doubtful that the landing burn would initiate. But then, there it was, igniting with a missing Raptor engine. Despite the hiccup, it achieved an impressive over 5 Gs of deceleration. It was a sight to behold. The booster hovered momentarily before gently kissing the ocean's surface, then gracefully tipping into the water. Exactly the finale we hoped for, met with resounding applause. Meanwhile, back at the launch site, as the booster executed its landing burn, the tower arms drew in. It was a thrilling moment. I had been hoping we'd see an attempt to simulate a catch. Fortunately, the arms were in perfect condition, unscathed by the launch, indicating no severe damage had occurred. Once again, Ship 29 triumphantly reached its intended trajectory, just shy of orbital velocity. In a curious twist, SpaceX momentarily lost the external camera feeds, but with a swift fix, the stunning views were back, and better than ever. It was clear that the adjustments to the attitude control were spot on. Ship 29 was perfectly positioned for re-entry. Intriguingly, this spectacle unfolded exactly 1 year after Ship 29 was first fully assembled on the launch highway. A poetic moment indeed. We didn't have to wait long for the re-entry. The early signs of plasma soon became visible, heralding the critical phase. Would Ship 29 handle the intense re-entry heating better than its predecessor, Ship 28? Absolutely, it soared through it. I urge you to watch the replay in real time. The entire entry was nothing short of breathtaking. Ship 29 not only survived peak entry heating, but did so without any visible damage. At this crucial juncture, the ship's upward angle allowed it to almost hover at the same altitude momentarily before descending further, allowing a more even distribution of the re-entry heat. This precise control was exactly what we were hoping to see. However, as Ship 29 continued its descent, the thickening atmosphere. As Ship 29 plunged deeper into the dense layers of the atmosphere, the tension mounted. The cameras, focused intently on the forward flap, began to relay heart-stopping images. Over the span of a nail-biting minute, the lower portion of the flap succumbed to the intense heat, melting through dramatically. Beneath, the support framing glowed ominously, visible as the outer steel was devoured and stripped away by the relentless inferno of the re-entry. This spectacle was nearly uninterrupted, a first in the annals of space exploration history. Despite its massive size, Starship managed to carve a path through the plasma, maintaining a channel to send back data, a groundbreaking demonstration of the new communication technology at play. But did this daunting challenge halt Ship 29's journey? Not in the slightest. Down it continued, with the now partially damaged cameras still capturing the forward flap in action. Astonishingly, it was not just intact, but actively controlling the vehicle, still alive, still maneuvering. The descent grew even more intense, with the ship rapidly falling below 10 kilometers. It seemed improbable that it would survive well enough to execute the flip and landing burn. But just when you thought it was over, think again. The remains of the forward flap moved, perfectly timed, orchestrating a maneuver that defied all expectations. As the ship initiated the flip, my heart raced. The landing burn ignited with a trio of brilliant flashes on the screen, signaling that all 3 Raptors were now blazing. I was speechless. The on-screen attitude control data confirmed that the ship was not only perfectly vertical, but also had nearly 0 velocity. Both Booster 11 and Ship 29 gracefully descended to their designated ocean splashdown points. The scene was utterly astounding, but the drama didn't end there. After completing its mission, the ship gently tipped over, and in a final act of defiance against the forces it battled, the flap broke off as it succumbed to the ocean's embrace. So, to recap, Booster 11 executed a near-perfect descent and achieved a soft splashdown. Ship 29, on the other hand, not only demonstrated a flawless descent, but also showcased the full prowess of its attitude control system, surviving the fiery ordeal of re-entry intact. What a monumental day. It's worth noting, as Elon Musk highlighted, that future versions of the Starships will see the forward flaps shifted more leeward. This adjustment is designed to prevent plasma flow from sneaking underneath and causing damage. Elon was quick to share these insights right after the event, underscoring a relentless pursuit of perfection in these celestial endeavors. Elon Musk has teased that for Flight 5, SpaceX might attempt to catch the booster using the tower. Imagine the spectacle. But was that all the excitement we had for the week? Not by a long shot. As we speak, another booster is taking shape. More on that in a moment. But first, I want to extend a huge thank you to XA for sponsoring this video. My wife and I have been fans of their sleek, minimalist wallets for years. With Father's Day around the corner, these wallets are not just stylish but also secure. Just load your most used cards, press the button, and watch them fan out neatly. Plus, with RFID blocking technology, your card details are safe from scanners. EXA offers a stunning array of styles and color options. There's something for everyone. Stay tuned as we dive back into the ongoing developments at SpaceX and explore what's next in the thrilling world of space exploration. Check out the super sleek and minimalist design of XA's aluminum card holder. It's my top pick for carrying a few extra cards along with some cash. For those who prefer a touch of luxury, the leather options are simply superb. And here's a game changer for someone like me who tends to forget where things are placed: EXA's solar-powered tracking card. It syncs with your phone, allowing you to locate your wallet with a simple app. It emits an audible ring to guide you right to it, and if it's your phone that's missing, just reverse the search. Problem solved. Don't miss out on these innovative wallets. Check them out through the link in the description or the pinned comment below, and don't forget to use the promo code HOUSE at checkout for an extra discount. A big thank you to XA for their support. Moving back to space tech, this week was a buzz of activity as Booster 15's aft section was transferred to the ring yard, a process closely monitored by Mary from NASA Spaceflight. After a quick detour to the Mega Bay to remove the stiffener ring, the setup for installing the temporary lead-ins began. These crucial components ensure that the two barrels are perfectly aligned before they're welded together. One by one, they entered the Mega Bay to be stacked. Unfortunately, these days we don't often witness the stacking events firsthand, as the doors usually remain closed. But the excitement behind those closed doors? Absolutely palpable. Exciting developments are unfolding at the massive test site this week. Once again, it was time for Ship 26 to be fueled. But this round included methane, along with the usual propellant, setting the stage for something spectacular. As we watched, more liquid oxygen than ever before was loaded into Ship 26. Anticipation was building, and then it happened. Our first static fire atop the new Masses Flame Trench. This static fire was not just any test, it was profoundly intriguing. If we replay the initial moments frame by frame, we can see a distinct sequence. The three Raptor vacuum engines ignite first, followed by the sea-level engines. This shift is significant. It appears the engine testing stand at Masses can now accurately simulate the startup sequence seen during actual flight conditions with the hot staging ring. Reflecting on the pace of progress, it's astounding to think that at the start of the year, work on the tank farm had barely commenced. In fact, around the time of the second Starship flight test, foundational work for the pad was just getting underway. Witnessing this rapid progression from foundational to functional is a testament to the relentless pace and innovation at SpaceX. Welcome to Blasovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blasovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe. Live Q&A sessions with experts. Your membership will grant you the chance to participate in live Q&A sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos, and join us in unraveling the secrets of the universe. Become a Blasovia Science TV member today, and together, we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comments.